have a crisis in American education today. According to the Program for International Student Assessment's 2012 study, United States high school students are earning average scores in reading and science and below average scores in math compared to 64 other developing countries.
The problem is that the majority of math and science curriculums put too much emphasis solely on the memorization of facts and mathematical processes. Textbook word problems train students to memorize a set process to solve only one specific type of problem.
Life is unpredictable, and rarely are its problems solved by cookie-cutter processes. Every situation is slightly different and cannot be solved the exact same way every time.
If our students are locked into relying on a different memorized process to solve every single problem in school, that habit will inevitably carry over into their everyday lives. Our students dislike school because they feel as though their time is being wasted. But why? Well, it's because we tell them that this math and science will help them problem solve in the real world. But it doesn't.
Current curriculums tend to focus primarily on the solution to problems rather than their formulation. Let's look at a typical textbook example problem. Notice that the problem to be solved is clearly stated in question form at the end of the paragraph.
In addition, all the information that you need to solve this problem is expressly listed in the paragraph. When do either of these things ever happen in real life?
Never.
Furthermore, notice that in this example, the student is told exactly what example problem to reference. There's absolutely no thinking involved. The student just has to memorize the process to solve the problems.
And what sense of accomplishment do they feel when they get the right answer? Look in the back of the book at a number, or the teacher says,
and the correct answer is 64 feet, 1 inch.
Whoop-de-doo!
I'm a teacher, and I know that this type of problem doesn't teach my students to think critically. Because if I give them a similar problem that uses the exact same equation, but requires them to do the reverse process or solve for another unknown, many of my students will quit or ask for help because it's not like the example problem. They again feel tricked, like I'm purposely trying to make them fail.
In order to teach critical thinking, a teacher must deviate greatly from the curriculum and recreate textbook problems to follow a better format. This takes a lot of time, patience, and planning.
But even with all that effort, many of your students will still not appreciate your subject matter because they still fail to see how these problems relate to the real world.
We then began to struggle with how to solve this problem of teaching critical thinking. And after doing much research and being inspired by educators like Dan Meyer, we came up with the Tetrahensive process, a 4-step, comprehensive problem-solving process specifically designed to teach critical thinking.
The Tetrahensive process takes a broader approach to problem solving. You see, rather than focusing on just memorizing a mathematical process, we emphasize the identification of a problem and the use of a wide base of facts to get to the correct solution.
Our process mimics the way problems are discovered and solved in the real world. Let's look at the same textbook problem, but in the manner that it would be presented in one of our Tetrahensive videos.
First, you see a video clip of something happening in the real world.
That clip would then lead you to ask questions about what is going to happen at the end of the video.
Thirdly, you will arrange the equations, facts, and measurements in a logical path that leads you to the correct answer.
In our videos, we'll call any equations, memorized facts, or processes tools. And any problem-specific measurements, we'll call those materials.
Just as you would gather all your tools and materials before starting a construction project, you must logically plan before you can construct your answer. This process can then be drawn out in a thought web to help picture the logical path that you will follow to answer the question.
Up to this point, you haven't done any math. In the last step, you calculate the answer.
But our process doesn't just display the number. We watch the rest of the video and see the real-world answer revealed.
By comparing your calculated ideal answer to what actually happens in the real world, you'll gain a greater appreciation of the work you're doing, because the theory that you're learning in the classroom actually does apply in the real world. Theory and reality are merged.
Interestingly enough, what happens in real life rarely aligns perfectly with ideal mathematical calculations. This is an amazing opportunity to continue thinking critically to determine what causes those minor discrepancies between the ideal and the real world.
Albert Einstein had it right when he said, "The formulation of a problem is often more essential than its solution, which may be merely a matter of mathematical or experimental skill."
Join us as we change the status quo of how math and science problems are presented so that more people can learn to think critically.
Each of our videos will be posted in 2 parts. There's also a worksheet that accompanies our problems. You can download the PDF by following the link.
Please try the Tetrahensive process on your own, or teachers, in your classrooms.
Then tell us what you think of our videos.
We encourage all of your questions, comments, editorial rebuttals, arguments, or disagreements that you may have regarding our videos.
And if you have any math or science problems that you would like to see recreated using the Tetrahensive process, please let us know. Tetrahensive.
Because thinking is critical.